Welcome back, programming students. Happy to have you here again for another grammar video. In this video, we're going to talk about the real kind of meat and potatoes, the key pieces to being able to write and define basic grammars. We're going to do a bunch of examples, and hopefully these will stick and make sense. So to start with, it's important to know how recursion works with grammars. This is not going to be as difficult recursion as Prolog in many cases. I think it's a little bit more straightforward. But hopefully a few examples here will help get you on the right path. So the first thing is, let's say we want to generate the language A plus, one or more A's. Well, this recursive language would work, right? Because I could either take A, which would just be one A, and A plus means one or more, so exactly one A. Or if I wanted more A's, I could add an A, and then I'd have to add this capital S, which recursively loops me back into this rule where I can substitute again. So I could take this rule, go in, choose a S, replace this S with just an A, and we would end up with AA. Or I could choose to go AS, AS, A, and get three A's. Or, repeat the loop 4 times, or 5 times, or 6 times. And so this would allow us to produce one or more A's. And the only difference between A plus and A star is that the terminal character for A star is a lambda, the terminal character for A plus is an A. Because this way you can choose to have 0 A's, or loop once and have one A, or loop twice and have two A's, and so on. So recursion lets us kind of write out some of these basic rules we've seen. So you can impose order by setting up rules in a clever way or a good way. So for example, we could have our sentence S, which goes to two symbols, an A and a B. The A symbol, or the A variable, the A rule, can be substituted with our A plus that we just defined above, and our B rule could be defined with B star, again following the pattern we defined above. So this would define the language A plus B star, right? So if you wrote the regular expression caret A plus B star $, it's the same thing as this grammar. So hopefully that makes sense. This also requires the order to be the same, right? This is only A's, only one or more A's followed by 0 or more B's. There's no way to, for example, go A, B, A, B. You can't do it with this language, right? Because we have a capital A, which only allows us to write A's, one or more A's. And we have a capital B, which only allows us to write 0 or more B's, and there's an order here. So the order that you write your rules, the order that you define things matters. So let's do some puzzles. So I call these puzzles, you could call them exercises, I guess. But really what it is an interesting way. What rules can you write to be able to write out other languages? So let's see, what rules could we write to write out A to the N, B to the M, where N is less than 2 and M is less than or equal to 2. Well, before we dive into the rules, let's think about this for a second. If N is less than 2, how many A's could we have? Well, we could have 0 or 1, right? So either 0 A's or 1 A, followed by either 0, 1, or 2 B's. So what would that grammar look like? Well, if you want to pause, please pause. But and I guess you at this point you should know if you need to pause to be able to try to get your own solution. Please feel free as we move through. Um, but let's look at the solution here, or a solution. There are more. Um, so we have S goes to AB. A goes to either A or lambda, so 0 or 1 A's. And B goes to lambda B or BB, so 0, 1, or 2 B's. You'll notice there's no recursion here, because if you start to have recursion, then you could potentially have infinite A's or B's or things that happen here. And so we don't want that. And so there are other solutions. If you found something else that works, please let me know. I'll help verify it for you if you're interested. And so then let's move forward. Let's do, instead of a limited example, let's do A to the N, B to the M. N is greater than 0, N is greater than 0, M is greater than or equal to 0. So one or more A's followed by 0 or more B's. Well, wait a second. This is just another way of writing the problem we already solved. S goes to capital A, capital B, A goes to one or more A's, B goes to zero or more B's, right? So this is A plus B star, right? So hopefully this ties together a little bit of that language notation. There's the regular expression way of writing it. There's a language definition way of writing it. Now there's a grammar way of writing it. There's also an automata version of this, right? So all this ties together, and what's interesting, as we'll talk about in future videos here, is that grammars are actually a lot more powerful, or at least a little bit more powerful, than automata and some other things that we've worked with. So we'll talk about what else that we can do with these grammars as we move along. So we have two more problems before I let you go. So the first one, this one's a little tricky. Um, Hopefully you'll be able to think about what this might translate to, but we want to write a grammar that generates all strings made of A's and B's, zero or more A's and B's that have exactly two A's. So let's take a second, let's pause the video and give you a chance to solve this one. All right, hopefully you paused the video and you're back now. So hopefully you gave this one a shot. Let's also give a shot at a grammar that generates the language of words composed of zero or more A's, where the length of the word mod 4 equals 0. In other words, to translate, um, this is a language composed of words where A is the only possible letter, and the length of the word has to be a multiple of 4. So 0 A's or 4 A's or 8 A's or 12 A's or 16 or 20 and so on. So try writing a grammar for this, pause the video, give it a shot, what rules might work for this. And in a couple seconds here, I will flip us on over to the solutions. All right, so first problem solution. This is, I think this is the rule that works for me, the set of rules that to me makes sense. However, if you have a different set of rules or you came up with a different solution that you think works, please let me know. I'll be happy to talk about it and chat about it. To me, what makes sense is any string with only A's and B's that has exactly two A's could be AA, or it could have a bunch of B's before the A's or between the A's or after the A's. It could have zero or more B's, either before, between, or after the A's, but the A's themselves have to just be the lowercase letter a. So I wrote this out to kind of follow our pattern. Really, we could write this with one rule or one fewer rules. If we just used lowercase a instead of capital A here, capital B, lowercase a, capital B, lowercase a, capital B, that would technically be a little more efficient way to write it, but I was trying to follow sort of the pattern we've looked at so far. So if we substitute all capital A's with lowercase a's, that ultimately does what I was talking about here. It's two A's and exactly two A's, and any number of B's before and after them. So this allows us to do B star. So it's kind of like a lowercase b star a, lowercase b star a, lowercase b star. Um, and so that would define that would cover any possible word that has two A's in it. If it starts with an A, we choose zero B's here. If it ends with an A, we choose zero B's here. So this just allows us to choose any sentence composed of A's and B's that has exactly two A's. And so the other problem, write a grammar that generates any word in the language of only A's, where the length of the word is zero, or is a mod, sorry, is a mod 4 is zero, so a multiple of 4. Well, you can write it this way. So S goes to either lambda, because 0 mod 4 equals 0, um, or 4 A's, and then loop back in to S. So this is an important rule or important feature of grammars, and we'll talk about how important this is and how valuable it is. You can write multiple symbols. You can make whatever substitutions you want that are within your language. So you can write 4 A's and a capital S. You can have multiple symbols every loop through, right? So this way we either add 4 A's or 8 A's or 12 A's or 16 A's or 20 A's or 24 or so on, and then we end. So hopefully that makes sense. Hopefully grammars have an instinctual click for you, but if not, we'll do plenty more examples and we'll talk about a little more trickiness that can happen with grammars in the next few videos.